Let's take a look at some specific examples of how you might use looping. In the first example here, as illustrated in the PowerPoint slides that we did in the previous video, you'll notice that I have just 4 print statements. If I run these, the result should be pretty straightforward, and that, as you can see, that the result is a rectangle that is 4 by 7 as I illustrated. But again, you'll notice how brittle this code is. I can't change this unless I actually change the code itself. And in general, your program should be flexible enough that you don't need to change the code to change the result of the output. So here's an example. If I change this now to a print statement from just a series of print statements to a for loop, I can use a variable which will then allow me to change the size of the rectangle. If I run this, it asks me now to enter the depth. Instead of a depth of 4, maybe I want a depth of 8. If I hit 8, you'll notice now that the code iterates 8 times, printing the 7 asterisks 8 different times. So I can in effect change the size of the rectangle, but just by entering a different value. What happens with this code is that the print statement executes 8 times. It goes 0, 1, 2, 3, 4, 5, 6, 7, which is 8 times. It never gets to 8, even though 8 was entered as the value of depth. That's the nature of the range function. Again, the first number is always inclusive, second number is exclusive, meaning it never gets to that value. Let's run this code one more time, and this time let's choose a different value, just to illustrate that we can change this at will. In another example, let's take a look at the print statement where we can actually print the value of I. Since this for loop runs 10 times, I becomes a different value each time the loop iterates. The first time through, I will take on the value of 0. The second time through, it'll be 1, then 2, then 3, etc. If I run this code, you'll notice the values print. And you'll notice that 10 never actually prints. That's, again, the nature of the exclusive nature of the second value. It only will get to 9. It will never get to 10. So let's take a look at the name Abraham Lincoln. Okay, and we can want it to print. In this case, this is the second type of for loop, where instead of iterating for a specific number of times, we're going to iterate a specific container. In this case, the string Abraham Lincoln. You'll notice the print statement on line 2, that simply prints an empty line, which separates the values a little bit. You can see the output a little bit better. And if I run this, you'll see now Abraham Lincoln prints. You'll notice the blank line immediately before the A. That's because of line 2. And then the letters in Abraham Lincoln print each one letter per line. This is, again, iterating a container, which is a different use of the for loop. Another type of iteration is iterating a list. Even though we haven't covered lists extensively in class, we will later in the semester. And in this case, I can iterate the contents of the list by going through and simply using the list, and then I say for president in presidents. Just like the string hit a different letter each time it went through, when you iterate a list, it will hit a different element, that is a different entry in the list. The first time through it'll be Abraham Lincoln, the second time through it'll be Harry Truman, the last time through it'll be Barack Obama. So if I run this now, you'll see it prints the 3 presidents one by one. For a while loop, while loops again end when there's some condition that is met. In this case, the loop will run as long as the variable another has the value of y. When the value of another changes from y to something else, it will actually terminate the loop. So this is one of the reasons why with while loops, you really need to be careful. When you create a while loop, check to make sure that the terminating condition, and that is the condition in the while loop, does eventually change. If it doesn't, your loop will never end, and you will have, in effect, what's called an infinite loop. If I run this, it now says, "You are awesome." Now I can run this as long as I want to. I can keep asking it to tell me how awesome I am to make myself feel good. Okay, this is great. So in the first thing in the morning, I might want to run this program. But eventually maybe I get tired of it and I say, okay, I'm ready to go face the day. And if I hit anything other than Y, including the letter N, of course, the program terminates. That's because the termination condition finally does kick in. Line 2 is no longer true because another is no longer equal to Y, so therefore the loop terminates, as does the program. This is an example of an infinite loop because, again, you'll notice that another never changes inside the loop. The variable another isn't even mentioned inside the loop because line 3 is the only thing that is printed inside the loop. So therefore, another will never change, and so therefore this is an infinite loop. If you want to know what an infinite loop looks like, just run this, and you'll see how fast this is actually executing. It's very interesting because I can run this all day. The computer will never get tired. It'll do it as long as I want to. Now, eventually, of course, you need to terminate this loop, and to do so, hold down the Shift key and hit the F5 key on your keyboard. That will terminate the loop, and you've broken out of your infinite loop. Again, don't be surprised that this does happen to you. It's not at all uncommon, and as I've mentioned, I've written many of infinite loops in my day. Just make sure that you know how to stop the loop, which does make things a little bit easier to get started on something else. I thought I would I thought I would end this video by showing you some examples of how you might actually use a for loop. Now, this is very interesting. I'm going to clear the terminal down here in the bottom. I asked the user to enter a starting number, then I asked the user to enter an ending number. The goal here is to create a table of numbers, and that is starting with whatever the user enters as the start number, ending with whatever the user enters as the ending number, and then print a table of the numbers. So if I run this, I could say, for example, let's say the starting number is 5, and the ending number is going to be, let's say, 15. If I run this, it creates a table, and it lists not only I squared, but also the square root of I. You'll notice in line 4, I generate a blank line, which you'll see right after the number 15 in the output. That spaces it out a little bit, and gives it a little bit more. It makes it easier to read. On line 5, then I generate the table headings. You'll notice that the \T, which is in blue. Those look a little strange, but those are called escape sequences, and they do generate a tab. It's nice because it helps line up the columns nice and even. Line 6 just prints the spacer, the lines underneath the table headings, makes it look nice. And then line 7 actually generates the loop. In line 7, we're going to start with 5, and again, remember in the range function, 5 is inclusive, so it will actually use 5. But the ending, I said, is 15. Well, the user wants the number 15 in the table. So because 15 would be exclusive, I need to add 1 to it to actually get to 15. So in effect, inside the range function, it is 5, 16, which means that it will actually get to 15. The print statement in line 8 then again uses the \T's, and you see the familiar F-string notation along with and the last entry there, the :.2f, which does round the square root to 2 decimal places.